Welcome to Mr. Chalk's Revision Tips. In this video, we will look at
reversible reactions, equilibrium, and what happens to copper sulfate. So, many reactions such as burning fuels are irreversible, so they go to completion and cannot be reversed easily. So reversible reactions are different. In a reversible reaction, the products can react to produce the original reactants again. So, when writing chemical equations for reversible reactions, the usual one-way arrow is not used. So instead, two arrows are used, each with just half an arrowhead, one at the top pointing right, one at the bottom pointing left. If a chemical reaction happens in a container where one or more of the reactants or products can escape, you have an open system. Reversible reactions that happen in a closed system eventually reach equilibrium. At equilibrium, the concentrations of the reactants and the products do not change. So we're summarising what chemical equilibrium is. The important things to note down is that it's happening in a closed system and the rate of the forward and backward reactions will be equal. The reaction between anhydrous copper sulfate and water is used to test for water. So the white solid turns blue in the presence of water. A similar reversible reaction takes place with anhydrous cobalt chloride, which is blue, and it turns pink when water is present. So if we look at an experiment where we could look at this, so if we've got copper sulfate, if we go and heat it up with a Bunsen burner, the water is driven off, leaving anhydrous copper sulfate. So if the Bunsen burner is turned off and water is added back to it using a pipette, the bowl would contain hydrated copper sulfate again. Cobalt forms coloured compounds. A pink cobalt compound reacts with hydrochloric acid. So the reaction would be pink cobalt chloride plus hydrochloric acid will turn to blue cobalt chloride plus water. So the forward reaction is endothermic. So when both cobalt compounds are present in the solution at equilibrium, the equilibrium mixture is purple. So the equilibrium mixture is called to explain what happens to the concentration of the pink cobalt chloride. So the concentration increases because the reaction or the equilibrium is moved to the left, and this is because the reverse reaction is exothermic. More hydrochloric acid is added, so explain what happens to the colour of the equilibrium mixture. It becomes blue because the equilibrium moves to the right and the concentration of blue cobalt compounds increase.
Thanks for watching.